Hello and welcome back to the video lecture series on Python programming. Today we are going to cover a very important topic, and that's Python modules and packages. So till now, whatever we were doing, whatever programs we were writing every program in the Google Colab pretty much in an interactive mode. That means we were writing some lines of code, executing them, seeing the output of that, again writing some few more lines of code, executing that. So that is the way we were doing the programming. Now, if you really want to develop large projects, right, or programs of large magnitude, obviously you cannot work like this. So generally what is being done is all the different lines of code, they are sequentially put in a single .py or the Python file, the Python source code file, and that is being executed using the command Python, and after that the .py file with the extension .py. But say for example the program is extremely large and it's a very complex program going to achieve something very complicated, say payroll processing, right? So for that, if you just try to write the whole bunch of code in one single .python file, .py file, that's going to be very complex, right? If you want to change that code later on, or if you want to make additions to the code, it will become a nightmare for you. So generally, what do we do for that? We try to, and that's a practice which is being followed by almost all programming languages. We try to break the whole program into logical segments, right? And the code for that logical block is being put in one single file, right? So that same concept is being followed in Python also. And the way it is being implemented is the Python module, right? So what do we mean by module? In Python, modules are basically they're the highest level of programming blocks, right? So highest level program organization unit. And when we say program organization unit, what do we mean? Basically, logically similar or doing the same kind of functionalities, those code are part of a same organization unit. That's the way it is supposed to be, right? Which packages the program code for reuse. That's something we are going to cover soon. Now, modules are being imported before they are being used. We have already seen that. We have seen some of the standard library modules which are there in Python, like the NumPy, the Pandas. Those modules are being implemented. First to do that, we have to import that. So that's there for any kind of module, whether that be standard modules of Python or be custom modules which are being defined by us. So both cases, we use the import, that is the import keyword, which is the first thing that we use. And what does the import do? It basically fetches all the modules. The module, say as a whole, the whole chunk of functions and namespaces which are there in a module. These are being fetched together. Other than that, we can also do a selective fetching by using the from keyword. What is the keyword? From, say, module 1, import this and this submodule or function, right? So that way we are not getting the whole dump from the module. We are getting a part of it which is relevant for the next set of coding, right? So that is being done using the from keyword, right? Now, why do we use module? Very simple. One thing we already have discussed, that logically we have to break the whole set of program, which is going to be a very large chunk of code, into smaller pieces or smaller blocks or smaller logical units. And each such logical unit or each such organization unit is a module. So that's what is the first purpose, to break it into multiple organizing components. That's the first thing. And each such component is known as a namespace. We can call it as a namespace. Generally, we try to give a namespace to a particular uh, module which is like very, what should I say, which reflects the function that it is trying to implement, right? So that's what we try to do here. Uh, Now, code reuse, that's the second very clear purpose. So if I want to use the same set of code from multiple programs, instead of writing it in different programs over and over again, we simply create a module, and that module we use in any program that we want to, right? So that is the same concept that is there for the Python standard libraries modules, right? So those are library modules which are being used by most of us in different shapes and forms, and we simply import and use it. So code reuse is a basic thing which is being catered, right? And third one, which is again very important, implementing shared services. So say for example, the same thing, I mean, it's related to code reuse, but a little different perspective. Say for example, for a payroll processing, I want to use a, a particular module which does the tax computation, right? So that tax computation module can be used by different other program also, not only in the payroll processing, even the employee portal may have a link to it. Now, if we don't have it as a common module, one is reuse, definitely that is there. Other thing is, say every time there is a change in the tax rules, I'll have to go and make changes in each of them, right? So that is a counterproductive exercise. So that's why if we make a single module and refer that from everywhere, wherever it is needed, when a change needs to be done, it can be done there only, right? That change will get percolated to the other programs, or rather whichever programs which use that tax computation module, right? So this is a very clear need for using modules. Now, let's try to understand how can you structure a program. So in C or C++ programming, we have seen that how it works. There is a main entry function, which is there to kind of get an entry point to the program. But how can you do that in Python? How can you implement a kind of a similar thing in Python? Very simple. What you can do is you can have a top level program, right? One program which kind of acts as a central uh, entry point, right? So let's name it as a.py. You can also name it as a main.py if you just want to be kind of following a same kind of a pattern that is being done in C or C++, right? So that becomes your central entry point. From there, different modules are being called, right? So say, for example, you have one module b.py, another module implemented as c.py. The module names will be b and c and all those stuff, right? So if you want to have a similar kind of a thing, so you can do it in the form of different py files, .py files. Out of that, the a.py file is the entry point, and all other .py files are the modules, right? The top level program and the modules, right? Now, when you try to kind of call the different functions, you can very easily do that. You can simply import that particular module, say import B or import C, and call the function from that module, right? So let's do something. Instead of just looking at the stuff from a theoretical perspective, let's also try to look at the stuff from a practical perspective, right? So let me first create a set of .py programs, right? So let me create a .py. So there is a b.py which I've already created. So which has a simple print statement followed by a function, right? Function one, which will print your messages, the parameter which is going to be passed, right? So this is the B. Same way, I can have also a C created. This C is going to be again a very simple Python program where I will have again function 2, say function 2, and I don't need any parameters, say for example function 2. I simply have it as print. This is function 2, right? This is func 2, right? And nothing of this sort, right? And I also define one more function, say function 3. Okay, and again it's just a print statement. This is func3. So now I have the two modules B and C ready with me, right? Now I create one more Python file, which is going to be the entry level file, which is the A, right? The main entry file, right? What I will do? Simple thing. I will just import and then B, and I will also import and I will name it as C. Okay, then I call the functions import func1 and that will expect a parameter. I will just give hey you, okay, and then I will call c dot, I'll just call the func2, nothing else. I will not call the func3, right? So this is done. Now I have to go to the Google Colab and I have to run this. Okay, I can do it from my Spider IDE also, but here we are, since we are doing everything in Google Colab, let me do that here also. Now, one thing we have to note here is I don't have the files a.py and b.py and c.py in the Google Colab, right? So from Google, the local drive, my local folder, I'll have to import these files, right? So I'll have to do that first. So what do I do that for that? I'll have to use the files.upload and I'll have to first upload the three files a.py, b.py and c.py. Only then it will recognize that there is something called a.py, b.py and c.py. Okay, so I'm just doing that only. And as obvious, the first time it takes a little bit of time and I'm doing that. So now I get the choose files option. I simply go to the working folder and I go to the sorry, this is in the Python programs, so Python programs, and I import all these three Python files, right? I do open, right? Now what it will do is it will upload the three files a.py, b.py and c.py. Now note one thing, this is very important and we'll cover that as a part of the theory also. I will import the B and C as they are being treated as modules, right? But I don't need to import A because I'm not going to treat A as a module, right? What it does when I do import, we will look into that. But just note this point first. Now I have to run this, so I'll just simply do a Python and then a.py. What will it do? It will simply run the a.py file, Python file. Okay, so let's see. So yes, b.py invoked for the first time. Your message is hey you. This was from the B, and then this is func2. Okay, this is by invoking the C, the func2 in the C module, right? So now you could see that I have three modules, or rather three files A, B, and C. Out of that, B and C act as modules, so we have to import that. And A acts as the main file, the entry file. So that file is being used to import B and C and call the functions from B and C, right? And I simply run the a.py from here, right? So this is how we can structure the program and run the program, right? Now let me go back. One very, very important thing I want to cover here. So we have already covered all this, so I don't want to spend time. How does the import work? When I say import B or import C, or for that matter, when we were doing import numpy as NP, what does it do behind the scene, right? So let's look at it. So as some people may think, it does a similar thing as hash include in case of C, right? But it is not exactly what it does only. Okay, it actually performs three distinct steps. And remember these three distinct steps. These are conceptually very important steps. The first thing it does is it finds the modules file. So when I say import C or import B, it will need to first find out B and C, right? So that is the find modules file. It will try to find the file corresponding to B and C. Second, compile it to the bytecode. So when we say modules file, I am talking about the source code file, right? We are talking about the source code file. But we cannot run a source code file. We have to compile it first, right? Unless it is already being compiled, right? So I have to compile the source code into a bytecode before I can run it. Next, I can run the code, right? So three steps. First, identify where the source code is located. Second, compile the source code unless it is already compiled. And third, run the compiled source code, right? Next, there are a few important points that you need to know. All these three steps will be carried out for the first time a module is imported. Okay, when I'm trying to import a module for the first time, it will uh, basically execute all these three steps, right? But when I have already imported a module, it is not going to do the steps again, repeat the steps again. The imports part will only execute because it may need to compile, but we'll see that, but it will not need to repeat the entire set of things. Okay, now in case the module is already imported, it already appears in a table which is named as sys.modules. So sys.modules is the system table which stores the currently loaded modules along with the timestamp, right? So once you check the sys.modules and see that the file is not already loaded, then only you are going to load the file or import the file, right? Then only you will start executing the three-step execution process, right? So sys.modules consist of the list of modules which are being imported already, right? Now each of the step, let's get into a little bit of a details. First is when we say find it, what does it try to find? So it tries to find out the source code, but just note it is not having any thing like the path is not given. Okay, so when I say import B, I didn't mention that the B is residing in F colon Python programs. Then the question is, how does it figure out? How can the interpreter figure out where the source code is located, the b.py, where is it located? Also, I'm not giving the .py extension so that it is going to add by default, right? But the question is, how can it figure out? That we are going to see. There is something called module search path, and we'll look into it in a little bit of details shortly. Using that concept, it figures out whether the file source file is located, I mean, it's there or not. In case it is not there, it's going to throw an error that I'm not able to find this file. Okay, please give that file to me first, and then I will execute the program. Okay. Next is compile. This is a very important thing that you need to note each and every point here. So the compile, when I do a compile, so it first gets the source code using the find it option, right? So once it gets it, it compiles the source code into a bytecode. Okay, when I say bytecode, what does it mean? It means a the pyc file. It's a Python compiled file, by a Python bytecode file, right? But before it compiles, it does one very important thing. It does check the file timestamps. Okay, the timestamp of the source file, source code file, as well as the timestamp of the bytecode file or the PWC file. So py file and the pyc file. In case the bytecode file is older than the source code file, That means the source code has been changed after the last compilation has been done. Only then the compilation is repeated, or it's a recompile being done, right? In case the byte code is more recent, the timestamp is later than the source code file, that means there is no change in the source code which has happened after the last compile. So nothing is being done. The compilation is not being repeated. That's the first thing that you need to know. So PYC file and PY file, the timestamps are being compared. And in case the PYC file has a older timestamp than the PY file, compilation is not being done because the source code has not been changed, right? One more thing which has to be noted is, in case there is only the bytecode file and there is no source code file, so it will simply load the bytecode directly, because what it means is the bytecode is being provided, the source code is not being provided. Some of the system, some of the what should I say, the Python library files, right, library modules, right, they will not have the source code files, you'll simply have the bytecode files. So for that, it will simply load the bytecode files, right? Nothing needs to be done, no compilation is required, right? So the program is being shipped as bytecode, there's no need for compilation again, right? So that's the second thing that needs to be noted. The third thing which needs to be noted is, uh, because you will see PYC bytecode file for the top level. So basically, the top level file, say here we are talking about a.py. We don't need to compile that because it's a top level file. We can just execute it from the from the console or whatever, right? So we don't need to compile that. Only if it is again used as a module for some other program, then only it will be compiled. Otherwise, the top level file, top level Python file is not being compiled. Only the files which are being used for the modules, they are being compiled. This is a very important point to be noted, right? Last step is the run it step. So you will just simply run the bytecode, right? This is the execution step. So this is how the whole import process works. Now I will do a small demo, right? So you have seen that if the, we have just talked about it, right? That if the Python import, the module import has already happened, it's not going to do that again. So let's check it out, okay? So what we will do is, we will try to import this b.py, the b.python file. So when we are trying to import a b.py file, what we are trying to actually do, we are trying to load the namespaces or the definitions, the functions, right? So if we are just importing the b.py, so let me write import b, right? Now what we will see is, we will see that the print function is being executed because we are the import is actually happening, the loading is actually happening. So the print will get executed. Now if I repeat the process again, you will see this line, this print is not being called because the import now finds out that already the module is loaded. There is no need for loading it again. So it's going to skip that. So let me do it. You will see that the print is not getting executed. So this shows that import only happens for the first time if it is already loaded. So how it is going to figure out? It is going to figure out from the from the syslogs file, right? So that if it is done, it is not going to repeat it again, right? Now, one more important thing I wanted to cover here, the module search path. Remember, we talked about the module search path. Now, we had a question. How is it going to figure out whether the file exists or not? And if it exists, which all directories, which all paths is it going to search through? So the first one it is going to search through is the home directory of the program, or the current working directory where the program is getting executed from. That is where it will search first. And just note one point: if a module is there, say b.py, we are keeping it in the home directory. At the same time, it is there in one of the subsequent directories. We are going to talk about that. Obviously, this one will get the precedence. This is going to override all the other versions. That needs to be kept in mind, right? So first, it's going to check the home directory. Next, if it is not finding in the home directory, then it is going to look at the directories which are being provided as a part of the Python path environment variable. I'm sure you all know about environment variable, and we can set values for the environment variables. We set for the Python path environment variable, we can set a number of strings, each of the string representing a particular file path. Say for example, C colon, then we give a semicolon, and we give F colon my programs, again a semicolon, then we give F colon my programs slash Python programs, right? So all these paths, it's going to look at it from left to right? So this is being done. Third one, it is going to look at the standard library. So standard library, we know that the standard Python libraries, they are being put into one of the Python paths, right? So the Python installation path, it is going to keep in a specific place of the Python installation path. So it is going to look at that particular path, subpath in the Python installation where the standard libraries are being kept, right? So that's the third place it's going to look at. And the fourth place, in case we have defined or we have set a .pth file, a .path file, okay, where also we have kept a list of strings, each string representing a particular directory or a particular path, that is going to be scanned. And what it is going to be done is every entry, so the home directory, the entries in the Python path, standard library directory, and the contents, the strings in the .pth file, it's going to concatenate and put it in the sys.path file. Sys.path will contain all the paths or all the directories where it can search through for that particular b.py. Okay, in case it is not able to find the b.py in any of the directories, then it will throw an error that unrecognized file name or something of that sort, right? Now, one more important thing here. In case you want to put your particular module in a particular location, right, which is not in any one of these four things, right, you have to make an entry either in the Python path of that particular directory or in the .pth file, because this is a default path, right, the current active directory, and this is also a default path. You can't make any change to it. So you can either add it to the environment variable, the new directory where you are keeping the program files for, or the modules, program modules for, or you can add an entry to the .pth file, right? Only then you will be able to make the interpreter understand where to find or where to search the module from, right? This is a very important thing that you need to note, right? Next, another important concept, like the modules, you can also have different modules clubbed up together as a package, right? You can put the modules in the form of a package, right? And how do you do that? It's a very simple thing. You have to create specific directory which should have the same name as you want to name the packages, okay? And if you want to have the sub packages, you have to have the sub modules. But how does the Python interpreter understand that this is a package? It is not an ordinary directory. For that, you have to put in this underscore underscore init underscore underscore dot py file. This is something which makes the interpreter understand that this particular folder represents a package or a subpackage. Okay, and within the package or subpackage, you can keep a module file, which is a .py file again. Okay, and you can do it. Now let's see. Okay, let's just find out how we can do it. So again, I'm going to go back to the Google Colab. Okay, let me go back to Google Colab, and before that, let me create a package first. Okay, so let me create a package. Say the same one, pack one. Okay, that's going to be my package, right? And within that, I'm going to have two things. One is the init and other is a module, right? So I will rename this A as underscore underscore init underscore underscore. So this becomes my init.py file. And in the simplest form, I can just keep it as blank. I don't need to give any entry to it. Okay, simply keep it as blank. And this B is just the same module, right? It's the same model. Let me just remove this print and just keep it here, right? So it's the same model, right? Let me name it as a little different. Say, let me name it as B1. Okay, so that we can distinguish. Now within this again, we create another folder for a sub package. So sub dash pack one. Okay. Again, if you want to make it feel, I mean, if you want the interpreter understand that this is a sub package, basically again we'll have to have a init file, and instead of b1 I can have a c1 here. Okay, and just change the function from func1 to func2, right? So now I have a pack1, and I have a subpackage subpack1, and within the pack1 I have a init, so that interpreter can understand that this is a package, and also a normal module. And within the subpackage also I have a init. Again, it has to understand that it's a package. Subpackage is also a package, and the module which we want to keep here. Right? So all set. But how can you access it from Google Colab? For doing that, what we will do is we will simply zip it up. Okay, we'll zip it up as a pack1. Okay, and we will simply go to the Google Colab and we will upload this zip file. Okay, we'll simply upload this zip file. So what do? I simply pick up this pack1.zip. Okay, once I'm done with this, it's going to upload it. Yes, I'm done. So now I have to unzip it. How do I do that? So simple, unzip. Okay, and then pack1.zip. That's it. Okay, so that will unzip the whole folder and the files under the folder for me. Oh, I'm sorry, I didn't execute. So I executed it. So it is done. Now, simply, how can I do it? Simple way, import. Okay, so pack1 dot, and it will immediately prompt. So b1 is the prompt. So b1. Okay, as, say I name it something, say b1 dash underscore dash. I just alias it. Okay, and then what do? b1 underscore dash, b1 dash, and then I do a dot. Okay, I should get the function. So func1, and I give a string, a simple string, hello there. Okay, hello there. And now I run it. What should it do? It should show your message is hello there. So this is for the modules under the package. Now, if I want to do the same thing and I want to do it for the sub package, so pack1 dot subpack1. So let me do something. From pack1 dot subpack 1 dot, right, C1. Okay. Okay, subpack is there is a dash in between. So subpack1 dot C1 import star. Okay, I do this and then I simply call, because I don't have to use an alias now. I have gotten everything. So function2 within bracket, this is subpack. Okay, sub dash pack. Now if I run it, why is that so? So subpack1, it is throwing an error. Let me figure out what is the error for. I have a pack1 and within that I have a subpack1. Oh, I have named it as, so pack1 B1, subpack1 I have a C1. So that should be fine, I guess. So what's the problem I'm getting here? Let me try to figure out. So pack1 dot subpack1 dot subpack1 and dot I gave a C1. Okay, let me just do an import and see. Import and see the same thing. Okay, as say C1 underscore dash, and then I have a C1 underscore, where is that? C1 underscore dash dot func1. Okay, so if I run this again, I get a error. So basically there was a small issue. We had used a dash in the name. I think that was creating an issue. So we have now changed it to subpack, just the subpack. So now if I do the same thing again, repeat the same thing again, C1 underscore dash, and then I do the function call, so func2, and then pass on a parameter. So this is C1 and I execute, it will get executed again. Okay, so this is how you can execute a particular package or a sub package and a module within a package or a sub package. There is one more option we can also do, like here we were doing like for the b dot c dot py or the b dot py, we were doing a import, right? Import star. I think I deleted that code. Anyways, so what we can also do is we can do a function, I mean single function import, right? Instead of the importing all the functions. So let me quickly show that one to you. So say for example, I have in B, I have this function func1. Okay, I want to add one more function, say func2. Okay, and func2 will simply print say this func2. Okay, and I don't need the parameter here also. I will just remove this. I'm just changing this B, and maybe I will just rename also to B to something else so that there's no confusion. So now what I will do is, for the first time, I'm going to, so let me rename this as B1. Okay, and then I'm going to import B1. Okay, first of all, I have to upload the B1 to Google Colab. So let me do that first. And as I do that, so choose files, I will take the B1. Now, let me show you. So I have this B1 now. Import B1. Okay, but I will not do like this. I will do from B1 import, which one? Just the func1. Okay, just import the func1. And then once I do that, what I will do is I will call the func1 and pass a parameter, hi there. Okay, If I run this, this should be no, there should be no problem. Now I will show you if I want to run the func2, it will immediately throw an error because when I imported this, I imported just the func1 function. I didn't import the func2 function, or I didn't do an import star, right? So that's why it will throw an error when I try to access func2. It will say that func2 is not defined as a name. So when you are importing, you are selectively importing just the func1. That's why I'm not getting the func2 as an identified name or namespace, right? So that's why it's a error throw, right? So this, if I just change this to star, I should have this problem eliminated. Yes, now it is func2. So these are some of the things that we need to understand when we want to do a full-fledged professional programming in Python. Obviously, we have to use the modules and also packages and have the code, bundled up first in terms of small modules, and then club up the modules from sub packages, combine sub packages from the packages, and then have one file, the entry file, right? Which we have shown in the PPT, right? So this one file will be my entry point to the program. And from here, I will be driving my program flow right here. This is my top level file, which I will have, right? This is the way we can structure and run a Python program. Hope this will clarify all your doubts about how to write a Python program in a professional world. So thank you very much and stay tuned.